Hello everybody, my name is Boris and we are continuing our story about thread indexes and the built-in thread variables. And we will show practical examples to have better touch with these things and to be more connected and know how to use them. We will give a couple of examples, and first one is one-dimensional kernel into threads, which is title of this kernel. We have one kernel function which will be turned into multiple threads. How many? It depends on the calling here, because in calling of the kernel function, we actually giving the number of threads that this function will be turned into, or how many copies of this function will be given here. Obviously, by giving exact numbers for number of threads and number of blocks, we are deciding actually that this function or kernel will be turned into one-dimensional array with one block of 10 threads, so we using only x-axis when we using these exact numbers. So these things need to be more exact explained, so let's continue with that. So we have standard include IO stream for to be used in the main program, but not much things are used here. Maybe just printf main program blah blah blah. But we are using for GPU programming or for the CUDA C++, we using this header or library to manipulate with this kernel function, which will be turned into multiple threads. So we have identifier global, which means that this kernel is called from host and executed on a device, which is GPU. So calling from the CPU and executing on the GPU. And normally we have defined, like for every and each of these threads which will be formed from the kernel function in this calling. Every thread will have its own built-in variable or index for the x and expected y, but maybe not, because we by the calling we are saying that this problem will be solved one-dimensionally or using just x-axis. So we have some variables idx and id epsilon in which we are giving these indexes to be used, so we can use them later in program. But for this first example, we just want to have touch with that, and for every thread which is made from this kernel, we have these indexes. But shall we have this index also filled by the calling? It's up to us to check in this program. So this is a kernel function, and we see the body, we just using printf. One note is that using standard C++ writing functions, it's not standard standard IO stream is not possible to be used in kernel function, but this from the C, it's possible to use. So that's one note. And if you going with the end of line and these that are these reserved words which are from the IO stream function, it's not possible to use them inside the function that is executed on device. Just this good old-fashioned schooled C printf. So we are writing in the body of this. We are actually we are writing some text, and we are writing down these indexes at the same. So don't forget this function will be executed in parallel. So it means that calling of multiple threads, every thread will be executed on one level. And if we have another function, it's not to be done sequentially, but instruction by instruction. So first instruction of all threads is executed, but then and only then it will be done another set of instruction for all threads. We can expand this example to check this what I said here. So we have, I think that we said enough about this kernel function. And then in main function, we are, let's say main program, and then kernels into threads. So I want to say by the name here that we are turning kernel functions into multiple threads. How many? Well, one block, so x-axis with 10 threads. That's obviously by the calling. We don't need, because we are just writing this down, we don't need another stuff. And here it says using only one dimension by calling with 1 and 10 inside these, let's say, bigger or less brackets. And also, yeah, maybe I should put here that thread.x is only available, but you will see that in the execution. So also CUDA device synchronizes to synchronize all threads inside, because it can happen that we cannot see all these threads and cannot see these texts. And I think everything is ready for compile and execute of this function. So let's continue with that. Okay, we will go like this. One, then also 1, 3131. That's the name of our file where this program is stored. Let's compile it. Make execute version. Okay. Then we can go to execute program 31, because this is exe version. So then, yep, main program, and then you can see the writing. I didn't put here turning into another row. So we have index thread x by x-axis 0 and epsilon axis 0. Then we have x-axis 1, and then still epsilon axis 0. So it is one dimensional. So this one stays 0. Maybe I should put here like this to see more things for this topic. Just to find the proper. Yep. Nope. Yeah. Then save. I'll save. Okay. Let's execute. Let's compile. And then execute. Yeah, you can see that we pick up all these threads by x, and the valuable index is this one, but this one stays 0, because by the calling of the function we said by the x-axis we have fixed number and one block, and by the for the blocks and for the threads, inside one block we have 10 threads, which is filled with where is used only x-axis, or this value is filled with these indexes, but this one stays 0, because here in definition we didn't use it. So I think this one is clear. I also want to show you, let's say, one more example, that you see that parallel instructions are done in parallel. So this is unnecessary. can erase this. We can call this part second instruction and go to new row. We can save it, file, save, and do the compiling. Okay, we compile it, then execute. Okay, no, not execute, this one. Yeah, you see, all instructions in parallel. First instruction is done in parallel, and then every of these threads are executing then second instruction after that. So we expected, like for example, this one write for the, let's say, first thread, and for the first thread to write down this one. But in reality, they are all threads which are formed from here are actually doing that in parallel. So when they're doing next instruction, which is here inside the thread, they doing the same time. So I think that we have a more let's say clear vision about what is threads executed in parallel, and then so by this second instruction line that we used, that for every thread that it coming after first instruction, which is done for all threads. So that's enough for this first example, and then we go on another dimensions to see and check how we can use it, and how we doing and expanding this story in a 2D or eventually 3D array of threads and indexes. So that's it for now. And until next time, see you.